Okay, we're going to do two of these. We'll start by doing just sketching the graph. We're basically working backwards from what we did just a moment ago. We need to find out the value of p, and we need to be reminded that a equals 1 over 4p. We need to be reminded of that because we need the p-value, because remember, the p is the distance from the vertex to the focus, and that'll help us to kind of set this thing up. So p, if we say 1 over 4 times p, and we see that the a value is actually 1 over 4, well, p has to be 1 if we don't want that to change. So if p equals 1, I know the distance from the vertex to the focus is 1. And that's a positive 1. And we have a y equals. Remember the last one we saw, we have an x equals, which is basically the same as the directrix. Something to kind of pay attention to there, that the directrix, if the directrix is an x equals, then your equation is going to be an x equals. We took that for granted when we saw y equals and a y equals, because everything was y equals, as far as we knew at the beginning. So with that in mind, we have an or a y equals here. So my directrix is going to be a y equals something, and it's going to be that far from the vertex. We don't have an h and a k, so our vertex is going to be at 0, 0. That value of 1 is the distance from here up to the focus. And as we said, the distance is the same, but it's the opposite direction down to the directrix, which is right here. Now we did on the first day another point on the parabola. Now that other point can be is basically 2 times the value of p parallel to the directrix from the focus. I said a lot there. Let me show you. From this x, I'm going to go, if you multiply 1 times 2, or the p-value times 2, I get 2. If I go over to the right, 1, 2, I'm going to put a dot there. If I go from here to the left, 1, 2, I'm going to put a dot there. Let me remind you that the definition of a parabola is every point that is equidistant from a focus and a directrix. So equidistant. This and this are 1, this and this are 1, so there's an equal distance. Here, from here to here is 2, and from here to here is also 2. And there's other ones in between, but those are basically, when we draw up an image of a parabola, we'll need at least 3 points to kind of get the general shape. So the easiest other points to draw are going to be 2 times p from the focus parallel to the directrix. Let's look at one more of those real quick. P equals -5. We look at the 20, we see the negative. We basically are going to divide the denominator of this by 4 if we know that this is 1 over 4p, because it's 4 times what would give you 20? Well, that's the 5, and what made it negative? It had to be a -5. Okay. We also know that the vertex is at h comma k. Well, h, if this is x minus h traditionally, well, that, to turn this into a positive, then this 2 had to have been a negative. So a -2 comma 0, because basically there's a +0 outside. Okay? So if our vertex is at -2, 0, we're going to go back 1, 2. We're going to put a dot right there. There's your vertex. Your focus is that many units away in that direction. And in terms of direction, it's a y, so that means it's a vertical. It's going to be either up or down, and that negative tells me it's down. So from here I'm going to go down 1, 2, 3, 4, 5. There's an x. It's going to curl around this way, and if I don't even think I can fit it, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 2 times that in this direction. So that's how wide it opens up. I can't even really go 10 the other direction. I'm way off the chart, but you can get an idea of the shape, at least giving yourself that much. I went 5 this way. I've got to go up 1, 2, 3, 4, 5 up. There's my directrix. You need to know each of these things to be able to get full credit on a graphing problem like this. It's a lot, but you do it enough, you'll get the hang of it.